Okay, we're going to have a look at domains and ranges. So domain is just a fancy way of saying the x values. So it's all of the x values of a function, and we're looking at that x axis. And then ranges is just talking about the y values, and we're looking at the y axis. So for example, if I had the graph of a straight line, y equals x, the x, or the domain, is just saying what is happening on the x-axis, and the range is saying what's happening on the y-axis. So we've got the range and we've got the domain. So for the graph of y equals x, the x values that go into that function could be anything at all. So any value of x could go in there. If we think about my graph, it continues on in both directions forever. So although we can't see it on the graph, it will carry on forever. So if we're just looking at the x-axis, x can be any number at all. And that's where we write x is an element of the real number set. And that's because the real number set includes every number that we know. The only numbers it doesn't include are the complex numbers. So it includes every number that we know. And then if we look at the range, the y values, we get exactly the same thing happen. So the y values can be anything at all. It's going to carry on forever, going as far down and as far up as we can. So the y, the range, is also an element of the real number set. Now if we look at a different graph, then different things might happen. So for example, let's look at the graph of y equals x squared. So y equals x squared looks something like this, and it carries on in both directions forever. And we've got my x-axis and my y-axis. I should label those. So on this one, the domain, the x values, they will go on forever in this direction, and they'll go on forever in this direction. So the range, the x, can be any number at all. And the range, the y values, now the y values, they can't give me anything below 0. It's not going to work. So that's not going to happen for a range. But the y values can be anything above 0, and they can carry on forever. So the y values can be any number, but with the condition that y is bigger than or equal to 0. And the reason it's equal to is because we know that the value at 0 does exist, because y, when x is 0, y is also 0 on the graph of y equals x squared. Now if we have a look at some other questions, so for example, if we look at a graph like a cubic, so a cubic graph might look something like this. So y equals a cubic, doesn't matter what cubic, and this is going to carry on forever in both directions. So again, if we look at the domain can be anything. It's not going to increase as far, but it will still go on forever. It's just the y values will get much bigger for them. And it will also increase forever in this direction. So again, x is an element of all the number sets. It can be anything at all. Now the y values can also be anything. So it doesn't look like a linear, but we still have that same answer. Looking at a different graph, what if we made a strange graph up? So what if we have a value where it goes to 4 and minus 3, but it doesn't reach that value, and then we get a value that looks something like this, and its top value here is 6 and 5, and this value here is minus 2, and this value here is 2. So this is a much more complicated graph. So the x values, the domain, will go any value from here to here. So it's anything between minus 3 and 5. So x is actually trapped between minus 3 and 5. And I need to decide whether it's equal to these values or not. Now it is equal to 5 because this is filled in, it's coloured, but it's not equal to 3 because it's empty. So my answer is -3 is less than x, which is less than or equal to 5. And then if I have a look at my range, my y values, it goes from, this is the lowest point of my graph, and this is the highest point on my graph. So it goes between these values here. So the y values, the range, go from -2 all the way up to 6. And this value here, it does equal it, okay, because the function does exist there. And at the highest point here, again, it does equal to it. So I've got -2 is less than or equal to y, which is less than or equal to 6. Another way to look at the domain and the range is if we do a mapping diagram. So for example, for the function y is equal to 2x plus 3, we can say that we have a domain and then we can look at the range. So for a domain of, for example, 0, 1, 2 and 3, this is my domain, which we know is the x value. And this is my range, which we know is the y value. So if my x value or my domain is 0, then my range, my y value, is 2 lots of 0 plus 3. And then the second one, my domain is 1, so my range is 2 times 1 plus 3, which gives me 2 plus 3, or 5. And then for the next one, I have 2 times 2 plus 3, so you might see it's a bit like a sequence this. So that gives me 4 plus 3, which is 7. And then the last one is 2 lots of 3 plus 3. So that gives me 6 plus 3, which gives me 9. So each of these functions maps, each of the domains maps onto one of the functions. And that's another way that we can look at the domain and the range. So in this instance, the domain, the x values, would be the set of numbers which are 0, 1, 2 and 3, and the range, the y values, would be the set of numbers 3, 5, 7 and 9, and that's my range.